This is section 3.2 in your book. It actually starts on page 244. The goal of this section is for us to be able to find zeros of quadratic functions and solve quadratic equations by using the principle of zero products, by using the principle of square roots. We won't be completing the square, although that's a goal of this section, and by using the quadratic formula. Now, the first thing we need to make sure we understand is what it means to find a zero. A zero is where your graph is going to cross the x-axis. So it's going to cross at a point, and we're only looking at the x value. Just remember that where something crosses the x-axis, now think about that. This is the x-axis, this one running this way. If something crosses the x-axis, the y value is a 0. So what we're going to be doing is we're going to be putting a 0 in place of f of x, because remember f of x is y, and we're going to be solving that equation. So in this very simple linear equation that we have here, if I put a 0 in for y and I solve it, I find that x is negative 2/3. Well, that's the x value. If I ask you to find the x-intercept, you would do the same thing, and your answer would be the ordered pair negative 2/3, comma 0. But if I ask you to find the 0, then the answer is just negative 2/3. They're the same concept. You would just give your answer in two different formats. Now, everything we look at in this section is going to be quadratic in nature. Now, quadratic means that it has that power of 2 on it. It's going to be a parabola. It could have a power, that's a little higher than that, but we would probably need to factor it down to get that power of 2. It's going to be in the form of ax squared plus bx plus c equals 0. The a and the b represent numbers. Let me show you some that would look like a quadratic equation. Now, these are all examples of quadratic equations. Notice on the first one, here's the first one, that 3 is a. It's written in this format, ax squared. This is a, x squared, plus bx, so b is 2, plus c, which is 3, equals 0. Same thing here. A is 1, b is 7, c is 10. You get to this one, though, and the problem is it's not in that format because in our format on the right-hand side, there's a 0. This one doesn't have a 0 here, so what you would do is bring the 4 to the other side, direct algebra, and you would add it to the 10 because it's a negative over here, so you bring it to the other side and make it a positive. So this would then be 14, and it would be equal to 0 now. So this 10 would no longer be here, this 4 would no longer be here, and it would be x squared plus 7x plus 14 equals 0. And then it would fit this format. So you would need to do that, if you had something that wasn't equal to 0. This one, again, is not equal to 0. So if I bring the 20 over, I get x squared plus 16 minus 20. 16 minus 20 is minus 4. It's now in that format, but some of you would say, doesn't look like that format to me, because in the format, I have an x squared, which I do have here. I have something with another variable on it, the x. I don't have that here. Well, really you do, because this is really x squared plus 0x minus 4 equals 0. So just in this case, the a is 1, the b is 0, and the c happens to be minus 4 in this case. So they're all examples of quadratic equations. Now, these are all examples of quadratic equations. They're all in the correct format. There are several different ways you can solve these. The first way is something that you should be familiar with by now, is by factoring. If we look at that first one, it's a trinomial. It has a 1 as a coefficient because it's 1x squared. That means that you can take factors of the last term, which is the c, that will add up to the middle to get your answer. The factors of plus 9 that add up to minus 6 would be minus 3 and minus 3. So we just simply put those inside the parentheses. Remember, this is our very basic factoring of trinomials. And we set each piece equal to 0. Now, it's almost pointless to do this twice because you're going to get the same answer both times. But if it came out to something that wasn't the same number, you would need to do it twice. And you would get x equals 3, Both times when you do this, if you repeated the process over here, you would still get x equals 3. So that means that the 0 here is 3. That's where this graph, this parabola, crosses the x-axis. If you were to graph it, it would cross the x-axis right here at 3, just looking at that one. So when I ask you to find the 0 of something like this, something that's easy to factor, you would just factor it, and that would tell me what the 0 is. The next one's not so easy. If you take a look at that one, it does not have a coefficient of 1. It has a coefficient of 3 in front of it. It can still be factored, and the way you check that is you say a times c. This is called the AC method because it's a, which is 3, and c, which is -2. Well, 3 times -2 is -6. If there are factors of -6 that give you whatever this number is, which in this case happens to be a 1, factors of -6 that equals 1, then it can be factored. Well, there are factors of -6 that equal 1. That would be 3 and -2, because 3 times -2 is -6, and 3 minus 2 is 1. So this is one that can be factored. Now, what you do when you factor those, and I'm just going to rewrite the problem here, is you take the two factors that you have found and you rewrite them in place of the middle term, and the middle term here happens to be a 1. So the 3 and the -2 will take the place of this 1x. So since the 1 has an x on it, the 3 and the -2 will also need to have an x on it. And right now all I'm doing is rewriting the problem with the 3 and the -2 in place of this 1. This should be a review for you, but I find that some people have a little trouble with this one, so I'm going to review it with you. Now it has 4 terms in it, and if you're familiar with factoring, and if you aren't, you really should go back and review that. But if you have 4 terms, now you're going to do grouping. I'm going to group each of the two sets individually and pull out a common term. In this common term, I will have a 3x, and I'll have x plus 1 left. You always bring down whatever sign this happens to be and do the same thing. In this set here, the common term is a 2. And when I do my division, -2 into -2 leaves me with the x. -2 into -2 leaves me with the plus 1. If you've done it correctly, these two will match. And my answer will be whatever this match is, because that now is the common term there, times the leftover, which is 3x minus 2. And you will take that factored group just like you did in the last set, and you will set each one of these equal to 0. So we have here that x plus 1 equals 0, which means that x now equals, this pen sometimes is a little hard to deal with, x now equals -1. And over here, do your basic algebra, 3x minus 2 equals 0. So 3x equals 2, which means that x equals 2/3. Now these are the zeros for this particular problem, 2/3 and -1. And we got that by factoring. So if you're having trouble with factoring, you want to make sure you go and review section R4 in your book. There was one more we wanted to look at. That was this one. And again, it's one that can be factored. Remember, this is a difference of squares. As long as you have a subtraction sign and two things that have square roots, you can factor it as a difference of squares. So this is one that can also be factored. You take the square root of each, and the square root of x squared is simply x, and you place them both in the two sets of parentheses that you have. The square root of 9 is a +3 and a -3. And again, if you do not know what I'm talking about here, you really need to go back and review that. This is going to come back to bite you. Set it equal to 0, just like we did on the others. And there are two zeros here. One is 3, one is -3. That's how you would do it if you were factoring. And there are several of them that can be factored. There will even be some that are already factored for you. Let's say you have something that looks like this. And it says find the zeros. Now, I know that your instinct is going to be to try to put this back together, but it's already set up for you. So all you have to do is set each one equal to 0, just like it is there, and solve. So you end up getting an answer of -3 and +2 there. So if they're already set up for you, don't do any extra work. Let's move on to the a little bit more difficult problem now. They're not so difficult. I just want to point something out to you. Both of these are problems that could be factored, but you could also use something called the square root principle with these, and you just need to remember a couple of things. They're set equal to 0 now, but if you decide to use the square root principle, they have to have the b term needs to be a 0 if you want to go that route. And in both of these, the b term is a 0. There's no x value there, so that means it's a good candidate for this one. Let's start with the bottom one first. If I were going to do this one, now granted, I could factor that, and I would factor that into x plus 7 and x minus 7. But you can use the square root principle. And what you do is you bring this back over, and again, it's going to need to be a minus there, so this will work. But if I bring the 49 over and I take the square root of both sides, you just need to keep in mind that the square root of 49 is not just 7, but it is also -7. There are two zeros there, the +7 and the -7. And remember, if you had factored it, you would have gotten those two answers anyway. So you can use the square root principle for that. You just need to, like I said, keep in mind that there is a plus answer and a minus answer for both of those. And you also need to keep in mind that this needs to be a minus. Now, if it hadn't been a minus, what would happen is, let's just put that in there. You look at it, and first of all, if you were going to factor it, remember you can't factor the ones that have pluses in them like that. There's no answer to them. We called those prime when we did these before. But what we do now is, if you can't factor them or you decide to use the square root property, you look at it and you go, well, here's a -49, and if I punch -49 in on my calculator and try to take the square root of it, it gives me an error message because you cannot take the square root of negative numbers. So what you actually do is you just say no real zeros, because we'll get into something that is called imaginary answers now, and we're not going to cover that in this class. In fact, if you flip to the back of the book and you check your answers on some of these, they will give answers, but they'll have answers like this one would be the answer that would be plus and minus 7 with an I beside it. It'll tell you that it's imaginary by having an I. So if you see answers in the back of the book that have I's beside them, what you should be getting for the purposes of this course would be no real zeros. That's what you want to put down for that one, or no real solution. If we take a look at the other one, the 4x squared minus 16 equals 0, we have a couple of methods we could use. Let me put it on another piece of paper. You could, of course, factor this one. You would pull out the 4, and you would have a 4 left inside. And we could factor this further. It's a difference of squares. And when we start to set things equal to 0, notice we have this 4 over here. Well, 4 doesn't equal 0, so we just disregard that. If there's no variable on it, we disregard it. Now, if it had had an x on it, we could solve that one. We would divide both sides by 4, and we would get 0 as an answer. But there's no x on it, so we can't solve it. It's not an equation, so we just disregard it. This one we get -2, and this one we get 2. So the zeros for this problem would be -2 and 2. And that's if you decided to factor it. We could go about that a different way, and we could use the square root principle. We could bring the 16 to the other side. We could recognize in this case that 4 will go into 16, or we could just go, well, 4 has a square root. I prefer to try to solve it like I would regular algebra and divide. And I get x squared equals 4. And now I take the square root of both sides, and I get x is plus and minus 2. And that's what this little symbol means. It means there are really two answers, a +2 and a -2. So we could go about that one either way. Sometimes you'll have problems that you might want to solve using the square root principle, but they don't actually have full-fledged square roots to them, like this one. If I bring the 7 over and I take the square root of both sides, I get x equals plus and minus the square root of 7. Because there is no perfect square root of 7, when I take the square root of both sides, I just have to leave it underneath the radical. You might have some things where you might want to simplify it, like we talked about in chapter 1, or you could put the decimal down if you wanted to. You would just need to tell me that it's approximate. I would prefer you leave it under the radical because that is more accurate. Now, we've talked about solving these by factoring. We've talked about solving them using the square root principle, but some of these problems you won't be able to do any of that to. You'll look at them and you'll go, well, they do have a b term. It's not a 0, so I can't use the square root principle. I've tried and tried and tried to factor it, and it just does not work. So what we do then is we use something called the quadratic formula. Some of you have heard of this before. Here's a copy of your quadratic formula. It says that x equals minus b plus and minus. Remember, that's when we did the square root principle, we always got plus and minus. Square root of b squared minus 4ac, and the line goes all the way across over 2a. If you come across a problem where you can't use the square root principle because you do have some b term and you cannot factor it, or you're just not good at factoring, this will always work. So this is the option. If some of you think, that you can't remember some of that other stuff, or you're horrible at factoring and you're trying to solve an equation, this is the way to go because it works for every one of these quadratic equations. That's why it's called the quadratic formula. It is the formula that works for every quadratic equation. So if you look at a problem and you can factor it and factor it easily, I would factor it. But if you look at the problem and it's one that can't be factored, or you're having trouble getting started with the factoring, especially some of you who need to do the AC method and you have trouble with that one, this would be the way to go. Let me show you some problems involving this one. Now, here's a problem that we might want to look at. If I started doing this one, I would probably check to see if I could factor it first. Factors of -20 that give me -8 might be -10 and +2. So that's one that you could factor. But if you don't recognize that, or like I said, you have trouble with factoring, you could also use the quadratic formula for this one. So we're going to start with a very basic, easy one to get us started on this. And this is one that we could factor if we wanted to. We wouldn't have to use the quadratic. We're just going to give you a good example of something easy to do first. So the first thing that you want to do is you need to determine what A, B, and C are in these problems. And they're just the coefficients. Remember, we said that all of these quadratic equations were in the form of ax squared plus bx plus c. So in this one, the A happens to be 1, the B happens to be -8, and the C, remember, it's got to be set equal to 0. So if there had been a number over here, it would need to be moved over here because it's going to make a difference in the signs. But the C in this case is -20. So we've determined what A, B, and C are. All we do now is we plug them into the formula. So here we have minus B. So we'll have this minus that's already there. And then the B, which is -8. So we end up having two negatives on that one. We have plus and minus, the square root, and we put our b squared, which is -8 squared. We want to use parentheses here, especially if we're using our calculator, so we get the sign right. Subtract 4 times a, which is 1, times c, which is -20. And there's a whole line that goes all the way across, and it's 2 times a, or 2 times 1. Now it's a matter of simply doing our math. We want to follow the order of operations, and we're going to start inside the parentheses. You want to be really careful about your signs. Now, if you take a look at what's inside here, if this is a minus, and this is a minus, and we're only looking at these three numbers here. This is the 4AC part we have. If this is a minus and a minus, then our math on the inside, this portion will be a plus. If this is a minus, this is a minus, and this is a minus, we have, we're doing multiplication, and we have a minus times a minus times a minus, then the whole thing would be subtraction. If we have two of them, the whole thing would be addition. If we only have one of them, like maybe this one's the only minus, then it would be subtraction. If this one's the only minus, it would still be subtraction. So please keep in mind your basic math when you do these. So a -4 times 1 times -20 is a positive 80, and that's what's going to go here when we do our math. We have a -8 squared plus 80. And remember again, if this had just been the minus, this would be a subtraction sign. If this is just the minus, this would be a subtraction sign. But if there's an even number, two of them, this is a plus sign. So right now, we have -8 squared plus 80. We still have the plus and the minus out here. And we have a -8, which is a positive 8. On the bottom, we have 2 times 1, which is 2. So we do our math here. We have 64 plus 80. So we have 8 plus and minus. 64 plus 80, let's see, 6 and 8 is 14. So 144, which comes out nicely because we do have a perfect square root of 144, which is 12. So we have 8 plus and minus 12. All that over 2. This means we have math for two problems. We have 8 plus 12 divided by 2 and 8 minus 12 divided by 2. So 8 plus 12 is 20 divided by 2 is 10. And 8 minus 12, well, the difference between 8 and 12 is 4, and the 12 is bigger, so 8 minus 12 is -4. Divided by 2 makes that a -2. Remember when I said we were going to factor? We had x minus 10 times x plus 2, which would have given us, once we set these equal to 0, it would have given us a 10 and a -2. So we ended up with the same answer either way we wanted to do it. It's a little harder, a little longer, not harder, but longer when you do the quadratic formula. But if you don't know how to factor or your problem can't be factored, then this would be the way to go. We need to do a few more examples because there are certain things that can happen. Okay, we're going to take a look at this one, and I'm not even going to check and see if it can be factored. I'm just going to go ahead and do it. This is actually number, see, where did I get that one? I got it out of your book. It's on page 258. It is number 46. And the directions up there say, use the quadratic formula to find the exact solutions. So the first thing you want to do is set it equal to 0. So you're going to need to bring the 1 across. Step 2 is going to be to determine A, B, and C. In this case, A is 2, B is -5, and C is -1. And you are simply going to plug them into your formula. Now, I would probably, until you learn what you're doing, I would probably copy the formula down every time. Remember that you have the option of putting formulas in your calculator. If you think you might forget this formula, I would put it in my calculator. Here's the formula. We have a B. It's minus 5. So right now, we're just simply plugging our numbers into our formula. You want to make sure you're accurate, so make sure that you plug all your numbers in, and then be very, very careful with your math. I start working on my math. I see that underneath the square root, underneath the radical, I am not going to have something that is a perfect square root because 25 plus 8 is 33. So right away, I know that I'm not going to be able to reduce it down any further because this only goes down to 3 times 11. There's nothing I can pull out of it. It is what it is. So I could leave it as long as this is reduced as far as it'll go. I can leave my answer in this format. Now I can also, if I want to, take and do 5 plus the square root of 33 on my calculator. and divide that by 4 and get an answer of roughly 2.686. That's a perfectly legitimate answer as long as you tell me that it's approximate. And then for the other answer, I can take my calculator and do 5 minus the square root of 33 divided by 4, which means that if I were to look at this graph, this would cross the x-axis at 2.686 and negative 1.87. Now, let me show you something on your calculator real quick. Let's go back to the original problem that we had. Now, if you go back and you look at number 46 in your book, this is the original problem once we brought the 1 over, remember, and made it in quadratic format. And we're trying to find the zeros. So if I take this and I put it in my calculator, and I actually hit graph on my calculator, I can confirm whether or not my answer makes any sense. Remember, one of our answers was negative 0.187. Well, that's before you get to negative 1. Here's negative 1. So this would be negative 0.187. The other answer that we got was a little over 2, I think. It was nearly 3, 2.6 something. So here's 2. Here would be 0.5, so that's roughly 0.6. But you can also, your calculator will even hone that further for you and help you find it. Now, I'm going to require that you show algebra, but there is no reason that you can't use your calculator to check yourself. So you can hit second trace on your calculator. Notice there is a zero function. If you hit 0 on your calculator, and you're going to have to do one at a time, notice it says left bound. So you're going to go to the left, or up really is what this means, to the one you're trying to find. Hit enter. You're going to now go to the right, hit enter, and you're going to go up now and you're going to guess what you think. And it says, notice at the bottom, it says x equals negative 0.1861407. Isn't that really close to what we got when we did the quadratic formula? And the quadratic formula, this format of the quadratic formula is even more exact than this is. This is just an estimate. But you could do that for the other one too. All you would need to do is hit, let's go back and hit graph so we can put it on our calculator. You'd hit second trace, go down for the 0 option. We want to go to the left. And left in this case, you know, if you turn your calculator kind of sideways, you can see that that's left. Hit enter. You're going to go right. That's right. And notice if you have selected left and right correctly, see how these arrows point into each other? They won't be back to back. They'll always point in. It says guess, so you're going to take your little arrow and go down where you think it is, and it says x equals 2.686 blah, blah, blah. And that's what we got when we did this by hand. So you can put this in your calculator. Now, if you put it in your calculator and you get one that doesn't cross the x-axis, let's say your problem is way up here, remember that zeros are where they cross the x-axis. So if you were trying to find zeros and it didn't cross the x-axis, you would have to say no real zeros or no zeros if we're trying to find the real ones. There's not any. It doesn't cross the x-axis, so it doesn't have any real zeros. Now let's take a look at one that comes out that way by hand so that we can see what it looks like. Now this is number 45 from the homework section. Notice there are a couple things that are out of order. You remember that quadratics are supposed to be in the order of ax squared plus bx plus c equals 0. And this one isn't. It's not in that format. So you need to manipulate it a little bit to get it in that format. So we would have the 3x squared. This is the one that has the x with it, so it's really the b term. And if I bring it over, remember it changes its sign. I'm going to plop it here in the middle so that I can put it in the correct place and set it equal to 0. So now it's in the correct format. A happens to be 3, b is negative 5, and c is 4. So we're just going to plug it into our quadratic formula. We're going to have minus a minus 5, and I'm going to just plug them all in. Now we want to do our math, so we're going to get a 5 here. We're going to go back and do our math inside. This is 25. And here's what I was talking about the signs. There's just one subtraction here. So the original answer, the final answer here is going to be a minus. And just do your math. 4 times 3 is 12, and 12 times 4 is 48. So we get a 6 on the bottom here now. If you look at this, 25 minus 48 is a negative number. If you get a negative number right here, you do not need to go any further. You just stop and say no real solution or no real zeros. Because this is a negative problem, you can't take the square root of negative numbers. Those are imaginary, so you stop. Anytime this is a negative and this area in here, this b squared minus 4ac part of your formula, it actually has a name. It's called the discriminant. And the discriminant can tell you a lot about the problem. If the discriminant is negative, that tells you there's no real answer to this problem. You stop. If the discriminant is positive, it tells you that you are going to get two real nice answers out of this problem. If the discriminant is 0, now think about that. If I was going to add 5, if I was going to say 5 plus 0, I would get 5. If I was going to say 5 minus 0, I would still get 5. So if this comes out to 0, you're only going to get one answer. Think back to the first problem that we did where we got a minus 3 and a minus 3 on both of them when we factored. So you're only going to get one answer for those like that. So that discriminant will help you out a whole lot. And there are actually some problems in the book that ask you what's the number for the discriminant, and it tells you that if you see that the discriminant is negative, you're going to have no real answer or no real solution. They actually tell you that you'll have imaginary answers. We don't care about the imaginary part of it. All we care about is that there are no real solutions to that problem. Now, there are a couple of other things that can happen, and I want to show you that. Let's say you do all your math and you get down to the bottom of your problem, and instead of, you're the type that you want to just reduce everything. You don't want to put it in your calculator and do 5 plus 5 squared root of 3, hit enter, divide by 15 and get decimals. You actually want to reduce it. So if these three numbers, all three of them have something in common, then you can reduce it. 5 will go into all three of them. So you would say 5 goes into 5 once. 5 goes into this 5 once. 5 goes into 15 three times. Those threes won't go into each other because that's a square root of 3 and that's just a regular 3. You don't necessarily need this one here because it's just like a variable. 1 times anything is just 1, so we can take that away if we want to. And our final answer would actually look like this. So you may have some things that happen like that. Keep in mind, though, that if there's only one of those answers, one of those numbers there, that will go into the bottom, like see how 5 will go into 15? You can't reduce this at all because all three numbers don't have something in common. It has to be like a triangle, all three numbers, for you to be able to reduce it. So that's another one of those things that you might come across when you're doing these problems. So you have several options here. You can look at the problem and you can try to factor it. You can try to use the square root principle, but remember to use the square root principle, the b term, the one in the middle, has to be a 0. So there can't be a number in front of an x value. You could also use the quadratic formula. That always works. You just need to get good at it. You need to practice it. There is an extra video in your account that goes over the quadratic formula. It's just one basic problem so that you can go through it again if you need to. But the main thing is you need to practice. You need to do the homework problems and make sure you're getting the answers in the back of the book. The only difference between the answers in the back of the book and what you will get on your paper is if some of you opt to use decimals, and the problems that have an I, a little slanted italicized I beside it, those, instead of getting the answer that they have in the back of the book, you would get no real solution. So that's the only difference. Remember, you can put these in your calculator, and if they don't cross the x-axis, you would know that there would be no real solution. If they do cross the x-axis, you can hit second trace and select the 0 option and go through that, and it will confirm your answer for you. Even the ones that are whole numbers, not just decimals, it will confirm the answer for you if you want to go through that. So that's 3.2 in a nutshell. If you have questions, please send me a message in Blackboard or send me an email, and I'll try to get back with you on that. But you've really got to do the problems that I assign so that you can get some practice over that.